Hello, this is the first session of a second series on matrices of the OCR Pure Core AS Further Maths. And today we're looking at reflections in two dimensions. We can represent a coordinate 3 minus 2 as a matrix 1 by 2. For example here, 3 minus 2. And if we pre-multiply by this matrix 0, 1, 1, 0, we would end up with minus 2, 3, as shown on the graph here. Or we can say that 0, 1, 1, 0 maps 3 minus 2 to minus 2, 3. If we look at the blue dotted line, that is the line y equals x. And in general, the matrix 0, 1, 1, 0 represents a reflection in y equals x. If we want to represent a 2D shape on a graph by a matrix, then we can do this by capturing the coordinates of its vertexes and putting them in an array or matrix, such as 0, 0, 3, 0, 3, 2, which represents the red triangle here on the graph. If we pre-multiply by the same matrix 0, 1, 1, 0, we would find that we had 0, 0, 0, 3, 2, 3, which gives us again a reflection in y equals x, as shown by the pink triangle on the graph. Therefore we can say that 0, 0, 3, 0, 3, 2 has been mapped to 0, 0, 0, 3, 2, 3. This should not be a surprise, as you can see that 0, 1, 1, 0 in effect turns around the x and y coordinates, so in effect swaps them, which is what happens when you reflect in the line y equals x. At these two matrices, we will see that when we pre-multiply xy by 1, 0, 0, 1, we would get x minus y. So in other words, if any point xy will be transformed to the point x minus y. This is therefore a reflection in the x-axis. Similarly, if we pre-multiply by minus 1, 0, 0, 1, we would get minus x, y as our transformed point. So any point xy will be mapped across to minus x, y. Hence you can see that this is a reflection in the y-axis. We have already met this matrix 0, 1, 1, 0, and we know that it in effect swaps the y and x coordinates. Thus it is a reflection in y equals x. For this matrix here, 0, minus 1, minus 1, 0, we will end up with minus y and minus x. Thus it is a reflection in y equals minus x. You may want to pause here and try out proof pre-multiplication by these matrices that represent various reflections for yourselves on different 2D shapes. You may also wish to consider the effect on a unit square, where we consider 1, 0 and 0, 1, along with 0, 0 and 1, 1, should we wish. And think about what happens in particular to those 2 points 1, 0 and 0, 1 under those reflections. To help you do this, you might wish to go to this GeoGebra website, either by cutting and pasting into your browser or by looking in Integral Resources. It's a really useful tool for investigating the significance of those unit square points and their images. You may also, of course, have linked these points 1, 0 and 0, 1 to the identity matrix that we covered in the first matrix series. In the next session, 2.2, we will be looking at matrices that represent rotations in 2 dimensions.